So what we're going to be finding today is the length of an arc. Okay? Now we've talked about arcs before, right? We've talked about major arcs, minor arcs, and semicircles. But every time we talked about an arc, we were measuring it using degrees, right? We would talk about like the degree measure of an arc. So for example, you can see in the picture right here, okay, we see arc AB, and its measure is labeled as being 60 degrees. Okay? But if we were actually to build this circle, if we were actually to like cut it out and make it so that it was a circle with a radius of 9 centimeters, this arc would also have a length if we could like measuring it using centimeters. We can actually calculate that length without having to measure it using the information that we have right here. Okay? So the arc length is just to be the distance along the arc here from A to B. So it's the distance we're talking about measuring now, no longer just a degree. Okay? So this is a piece of the entire distance around the circle. Alright, so the first thing we're going to do is find the circumference of this circle. Okay, so there's a circumference formula given to us here. It's 2 times pi times the radius. Okay, our radius here is 9, so we'll just type into our calculators 2 times pi times 9, and we get 56.5. So we'll round that maybe to the nearest tenth. Okay, so we'll say 56.5 then is the circumference here. Okay, and that's in centimeters. Okay. So now that, again, that's the full distance around the entire circle. But we don't want the full distance. The directions here say to find the arc length of AB. We want to find just the distance from here to here. Okay? Which is a piece, which is a part of the full circle. Okay? The entire circle goes 56.5 centimeters around, approximately. We want to find just this piece. Okay? So letter B says the entire circle has 360 degrees, right? If we go the whole way around, we can also say it's 360 degrees. Therefore, the arc's length is 60 out of that 360 degrees, right? It's a 60-degree piece out of the entire 360 degrees, or 1/6. Now, how'd they go from 60 out of 360 to 1/6 like that? Yeah, we just simplify the fraction, that's it. So 60 out of 360, you can see in your calculator, it does it real quick for us. 60 over 360, if you hit math, enter, enter, it simplifies it to 1/6. Okay, sorry, you can barely see that. There you go, 1/6. Okay, and that does simplify there. So we're going to fill in the blanks then to find the arc length. So we're going to find the arc length of AB, we're going to take that 1/6, and we're going to do 1/6 of the circumference. Well, our circumference here is 56.5. So we're going to do 1/6 of that 56.5. So 1/6 times 56.5, 9.4 we'll say. Oh, it's, alright, whatever. Alright, I don't know why it's having us do this twice there, it's kind of silly. Anyway, 9.4 centimeters. Okay. So again, I don't know why we're having the or there. I think they maybe didn't want us to multiply out the pi just yet, but sorry. So 9.4 centimeters is our arc length, okay? So if we made this circle, making it actually with a radius of 9 centimeters, okay, then the length, the distance from A along the circle there to B would be approximately 9.4 centimeters. Okay? So that's kind of like how we find the length of an arc. All right, it's just a fraction of the circumference. All right, questions on any of that? All right, so the little reflection question here is something we could ask then. So how could you use this reasoning process above to find the length of an arc of the circle that measures m degrees? So if instead of the arc being 60 degrees, if it was just a generic m degrees, what would change here? Okay, would we still have to find the circumference of the circle for a generic arc? No, yes.
What's a generic arc?
So I guess what I mean is like, let's say for example I wanted to find, if the measure was m degrees, what I mean by that is like, let's say in this specific case we wanted to find the length of an arc that was measure of 60 degrees. But let's say I wanted to find the measure of an arc on the circle that had a 50 degree, or a 100 degree, or a 180 degree measure. What would need to change here? In this process that we just did. Remember, we first found the circumference of the circle, we found the circumference of the entire circle, then we found the fraction of the circumference that we wanted by taking the arc measure and over 360.
So do you just put that in your calculator, 56.5, then math and fraction? No.
So let me finish my question first, and then we'll get to yours. So again, if I wanted to find an arc measure of something other than 60 degrees, what would need to change here? So let's say I wanted to find the measure of a 90 degree arc along here. What would have to change? So the circumference, would that change if I wanted to find a 90 degree arc? The circumference would stay the same because I still have a 9 centimeter radius there. So the circumference would still be 2 pi r, it'd still be 56.5. But yes, Julio, you're right, it'd be the fraction that changes here. Instead of a 60 over 360, if I wanted to find like a 90 degree arc, what would it be instead? It would be 90 over 360, okay, because it would be that fraction, okay? So, and here for number 1, if I wanted to find an m degree arc, it would be m over 360, whatever that arc measure is, times then 2 times pi times the radius. That's the circumference piece. We're finding like a generic formula, okay, a generic formula. Rather than always having, rather than like doing what we did right back up there, we're just kind of using a generic formula. So we're going to take the circumference and multiply by whatever fraction of the circumference the arc is, whatever the fraction.
Why is it so cold in here?
I can't control it, I'm sorry. And I don't know, the heat was not on overnight or something like that. It was really cold inside. I'm sorry, you need that, Ramel? Sorry. All right, yes, Caleb.
So you got the fraction by doing 60 over 360?
Correct.
But what if there was more than one measure on the circle?
Well, we would have to maybe combine those together. It depends on what we're being asked for there. But if we would only want to put one number over that 360.
Right, and you simplified it by divided by 60?
Yes, you're welcome. Okay, Ramon, thank you. Okay, so, yes, exactly. So if we look here, and so that is, in fact, the generic formula for arc length. The arc length, and they use a little s for arc length of an arc with measure m degrees and radius r, is given by the formula s equals m over 360 times 2 pi r. Okay? All right, so let's see an example of that here. So, on a clock face, the minute hand of a clock is 10 inches long. Okay? To the nearest tenth of an inch, how far does the tip of the minute hand travel as the time progresses from 12 o'clock to 12:15? So here's the clock pictured. It's at 12 o'clock. And when the minute hand goes to 12:15, which is right here, okay, we want to know how long or how much distance has the tip of that minute hand kind of traveled to go from there to there. Okay? Well, so let's see here. What is the degree measure that it traveled? To go from 12 to 12:15, what's the degree measure that minute hand had to travel? Yeah, it's 90 degrees, right? It's 1/4 of the circle. 1/4 of 360 is 90 degrees. So yeah, it's going to be 90 out of the 360 degrees, okay, times,
I thought we were dividing.
yeah, 90 divided by 360.
Why are we timing?
Well, because we have to take this and we multiply it then by the circumference of the circle, okay? Because again, we want to find the distance that it's traveling. So 2 times pi times the radius. Now, the radius in this case, what is the radius? Oh, the very next page from now. Sorry, the very next page. So, nope, not 5. Where are you getting 3 from? Oh, because it goes to the...
I have no idea.
I'm not where 3 is coming from. It's 10. It would be 10.
How?
So 10, because the minute hand is 10 inches long. Okay? So that means this minute hand starts at the center and it goes out 10 inches from that center. So it's times 10 is the radius.
I just thought we'd have the picture.
Oh, no. We're told there in the directions it's 10 inches long.
Wait, no, don't you have to divide by 2?
Divide what by 2?
10?
No, because again, the minute hand of a clock, it starts at the center of the circle and it goes out. So it's not the diameter, it's a radius, right? But good question, though. Thank you for asking that, okay? So, all right, now you just type this into our calculators here. We can multiply this out. So I would type 90 over 360 as in parentheses there. You guys see that? Okay, it's kind of like reflecting. Okay, times 2 times pi times 10. Okay? So pi is second and then the caret. If you don't want to use the pi button, you can also use 3.14. That's fine too. If you don't have a pi button, just use 3.14. Okay, so we get about 15.7. So that means the tip of the minute hand is going to travel 15.7 inches from 12 down to the 15 there, or down to the 3, I guess. So this is a linear distance. We're not talking about an area. We're talking a distance that it's traveling. We'll talk about this area of this sector in a second, okay, or a little bit later. But right now we're just talking about it's a distance that it's traveling. The tip is traveling a distance. So like you could measure it. It's like a linear distance. We're just going from here down to here.
Right. So why wouldn't it be inches squared?
Well, so let's look at what we let's look at what we multiplied. We have 90 degrees divided by 360 degrees. So the degrees are going to like cancel out because it's degree divided by degree. So they cancel. 2 is just it's a number. There's no inches there. Pi also not inches. It's just part of the formula. 10 is in inches. So it's only inches that we end up with there. Okay? All right. All right, so now the next one here, the minute hand of a clock is 6 inches long now. To the nearest tenth of an inch, how far does the tip of the minute hand travel as the time progresses from 12 o'clock to 12:30? Okay, so now how many degrees is that? From 12 o'clock down to 12:30, how many degrees is that? 180. So now we're going to say 180 out of 360 times 2 times pi times the radius. Now what's the radius in this case then?
6.
It's 6. The minute hand is 6 inches long. Okay, and again, that we just type into our calculator. 180 divided by 360 times 2 times pi times the radius of 6. So 18.8.
Inches.
Yep, and in inches again, because that's what the minute hand was in. Okay. Okay. Questions on any of that? Okay. So we're going to skip on to let's see here, page 8. Yes, page 866. I want to talk about a different kind of way to measure an angle. Okay. What's that?
Like, are you talking like protractor, how to measure angles?
It's like a different unit for measuring angles. So normally we measure angles with degrees, but now I'm going to talk about a different way called radians. Okay, and it's very similar to degrees. There's a conversion, and that's all you have to do. Okay, so the way radians work is basically like this. All right, we know that to go around a circle, we can go around a circle with degrees. Right. So if I do that in degrees, going around a circle is 360 degrees. But also, we know how to measure around the outside of a circle too. What's the measure that what do we call the distance around the outside of the circle? We've been talking about it, like we talked about some yesterday, we talked about some today actually too. What do we call the distance around the outside of the circle? We don't call it the perimeter of the circle, we call it the what? The circumference. The circumference is the outside of the circle. So what is the circumference formula for a circle? C equals, in terms of the radius actually, please.
Isn't it 2 pi r?
Yeah, it's 2 pi r. I'm sorry. Or pi times d, too, if you want to use that. But I'm going to use this one because that's the way we kind of set up with radians. Okay? So, one way we can use to go around the outside of the circle is 360 degrees. Another way we can use to go around the outside of a circle is circumference is 2 pi radian, or radius, 2 times pi times the radius. Which what this really means is if you draw a circle, if you have a circle, and you measure a radius, okay, you measure off a radius, and if you count how many radiuses it takes to go around the outside of the circle, it's going to take you 2 pi radiuses. which is about 6.28. So if you like measured a radius and you were to measure 1, 2, and count 1, 2, 3, 4, 5, 6, it would be a little bit over 6 to get back to that starting point there, because a circle, okay, is 2 pi radiuses in its circumference like that. So these two things are measuring the same thing, but just with different units. And so we can say then, and what we're kind of doing here, it's a little bit of fuzzy math, but it's basically the idea, okay, is that 360 degrees is kind of saying the same thing as 2 pi r. And instead of saying radiuses, we're actually going to use the word radians. Okay? And so we get this kind of like conversion here. Radians, you'll notice there's no degree here because we're not talking about degrees. It's a different way of measuring. We have 360 degrees is equal to 2 pi radians.
Yeah, but radius never had a degree.
Right, exactly. It's a different way of measuring things. Instead of saying degrees, our units are radiuses, or radians is what we're going to say here. And that's all. Okay? And so what that means is, so for example here, if 360 degrees is 2 pi radians, what would 180 degrees be? It would be 1 pi radians, or just pi radians if you want to say that. Okay? 360 divided by 2 is 180, 2 pi divided by 2 is pi, so it's pi radians. Okay? Yes, I can zoom in some there. Okay? So that's the basic idea here, and there's lots of different, any degree measure we can convert into radians. All right? But there's like some of the two basic ones. 360 degrees is equal to 2 pi radians, 180 degrees is equal to pi radians. Okay? But we can actually convert from degrees to radians, and then from radians to degrees. And I'll show you how we're going to do that here in a second. Okay? But we're going to use this idea that 180 degrees is the same thing as pi radians. I know it's kind of weird that pi is like one of our numbers here that we're using, but it is. Are you okay now? Okay. So, letter A, okay, it asks us here to convert each angle measure to radian measure. Okay? But we already know, what is 180 degrees in radians? We just said it. It's pi radians. Okay, 180 degrees is pi radians. Okay, so we don't need to do that conversion. But what about 60 degrees though? What would that be in radians? Does anyone have an idea? Anyone want to guess? If 180 degrees is equal to pi radians, anyone want to guess what 60 degrees will be in radians? What's that? Not 6, not 6.
It would be under 0.5, right?
It would be under 0.5, yeah. It is, so 60 degrees is less than half of 180, so it'll be less than half of pi.
Probably 4.
What fraction is 60 of 180?
1/2.
Not 1/2, nope. All right, well, let's take a look. Let's just do it then. It's 1/3, yeah, it's 1/3. So it should be 1/3 pi, and that's what it's actually going to be here. So if we do the conversion, let me just show you. So we know that 180 degrees is equal to pi radians. Okay, and we're going to just make a little proportion thing here. Actually, let me do it over here because it's not going to happen. I'm not going to have enough space if I do it there. So we'll do it over here. So we're going to say that 180 degrees is over pi radians. Okay, that's like a little ratio we're making. And then we're going to set that equal to, and then we're just going to convert it.
So why 180?
Because that's what matches up with pi radians. We're matching up two things. I could just as easily say 360 over 2 pi if I wanted to.
Okay.
So now over here, I want to find 60 degrees, so I'm going to convert 60 degrees into some number here. I don't know this number for radians. That's what we want to try and find.
Did you cross multiply?
So yeah, exactly right. We just cross multiply here to solve this. So I'm going to multiply that to that, multiply that to that. X times 180 is 180x. Pi times 60, I'm not going to actually multiply the pi and the 60 together. I'm not going to do that math. I'm just going to write 60 pi. Okay? When you deal with radians, you leave it in terms of pi. You don't generally multiply 60 times 3.14 or anything like that. We leave the pi kind of out. Okay? So that's the idea there.
Do you divide by 180?
And exactly right. We want to get the x by itself here. We have to divide both sides by 180.
How do you do that though?
I'll show you. We're not going to do that. We're going to simplify. We're not going to divide. Okay? So again, pi doesn't really simplify with 180, but the 60 and the 180, they do simplify. If you use your calculators here to help you, we can type in 60 divided by 180. I'm going to hit math, enter, enter, and it converts it to the fraction there, 1/3. Okay, so 60 over 180 is really 1/3 pi, or sometimes you'll see pi over 3. Okay, either one. Either one's acceptable there.
So, you really have x equals 60 pi divided by 180. Like, because I wrote it out as a fraction.
Yeah, mm-hmm.
Okay, and
60
then,
pi over 180. That could be the answer too, but I just wanted to simplify the 60 over 180.
oh, so that could,
You could stop right here and say 60 pi over 180, that's true. But we normally simplify that fraction of 60 over 180 to 1/3 or pi over 3. 1/3 pi, I should say, or then pi over 3. Okay? So that's in radian measures. So 60 degrees is equal to 1/3 pi radians, or pi over 3 radians. And it's just a different way of measuring. It has to do with the number of radiuses around the outside there. All right, so let's try one more together here, and then I'll have you guys try one on your own, and then I'll give you guys your assignment. Okay, this is the last thing we're going to look at today. Okay, so let's finish with these two, and then we'll go. I'll have you guys get into your assignment. All right, so let's look at number 7 here. We want to convert each angle measure to radian measure. So we have 90 degrees. We want to convert that into radians. So again, I'm going to start with a radian and degree measure that I know. I know that 180 degrees is the same thing as pi radians. Okay? I'm going to set that equal to, all right, and let's see here. So Jason, that 90 degrees, where should that end up here?
On the bottom.
Where does it match up?
On the top.
Yeah, it should go on the top because it's 180 degrees go on top, so the degrees should go on top here, 90. And then what should I put down here?
The R thing.
Right, we don't know what the radian is. I'm going to use x, though. I'm going to use x. We don't know what the radian is yet, so we're going to use x. Or you can use an r if you wanted to. That's fine. Okay? And now to solve this, Jason, what do we do?
You can cross multiply.
Yep, you got it. Cross multiply here. So we're just going to cross multiply. So I get x times 180 equals 90 pi. Again, don't multiply that pi out. Okay. We'll divide both sides by 180. You get x equals. Now, 90 over 180. Does anyone know what that simplifies to off the top of their head? It's a half. Yeah, very good. Some of you guys do that right off the top of your head. That's good. Or if you use a calculator, that's fine. Okay. So you can say 1/2 pi, or more usually, you'll see pi over 2. Again, we just multiply the pi up into the numerator there and get pi over 2. So either one's acceptable, but if you want to get kind of like in good habits for what you're going to be doing later in your other math classes, pi over 2 is what is the more familiar kind of way to write that. Okay? Questions on number 7 there?
No.
All right, then go ahead, please, try number 8. Okay, so give number 8 a try. I'll leave number 7 up there for you to see, and go ahead, please, try number 8. Okay, try number 8. Okay, so convert that 45 degrees into radians, and I'll come around and check here. I'm going to do it first, and then I'll check for you. Question, Garrett, 1 second. Let me finish here real quick, and then I'll be right with you. Okay. So really, you can use any radian and degree, or degree and radian measure that you know. So for example, I also showed you, right, that 360 degrees goes around the outside of the circle, and then 2 pi radiuses go around the outside of the circle. So you could also do 360 over 2 pi. That'll work as well. In this case, though, I think the best one to use, and the easiest one, is 180 over pi. It involves the least amount of work. So to answer your question, you don't have to, but if you want to, you always use 180 over pi. Yeah, and it's going to be the most efficient. But you also could use 360 over 2 pi. You'll get the same exact answer as if you use 180 over pi. Yep, for 1. So to simplify that, with a calculator, you hit math, enter. 145. Questions on anything? We're all good? That's okay. Typically, we don't. I mean, that's fine. You 0.25, you also write 1/4 pi, and then that becomes pi over 4. So that's typically you write it as a fraction. Okay. I have I can get you a wet wipe there, Jordan, to help you clean that up. So if you're having trouble wiping it up. Yeah.
I have a question.
Okay. Yeah. Just do 90 and 180. Simplify out. 90 or 180. Simplify that. Simplify that. Yep. Okay, yes. Good? No, okay. We'll just continue. All right, so let's go to, Ramel, what'd you get there? Pi over 4 is correct, okay? Lots of other ways you could write that. You could write 1/4 pi. I thought 0.25 pi. That's okay as well. But again, if you want to get in like the habits of what you're going to be doing later in your math classes, pi over 4 like this is the most typical way we write that. 1/4 pi is correct. 0.25 pi is correct. Pi over 4 though is the most usual typical way that we write it. Okay, we put the pi up in the numerator like that. But it's not wrong to put 1/4 pi over 4. Okay, Garrett asked a question I want to kind of hit on real quick. He was asking, so do we always have to use 1/80 over pi? The answer is no, you don't have to use 1/80 over pi. Let me just show you real quick here. You can use any degree and radian measure that you know pair up. So for example, we also said that 360 over 2 pi is another like pair there that we know, the degree measure that matches up with the radian measure. And so you can just do the same thing, and you'll see that we end up with the same answer here. This is the last thing here, folks, and then we'll finish up. 45 times 2 pi, 45 times 2 is 90 pi. So if I divide both sides by 360, okay, 90 divided by 360, whoops, 90 divided by 360, math, enter, it's 1/4. Okay, so we still end up with 1/4 pi, which is then really just pi over 4. Okay, so you can see you end up with the same thing using a different radian and degree measure pair that you know. Okay. So we talked about two different things here today, all right? Let me just summarize here. We talked about arc length. That is, if you were to actually build this circle and measure around the outside using like a ruler or a piece of string, and then measuring that piece of string, because obviously it's hard to use a ruler because you can't really bend a ruler that well. Okay, but a piece of string maybe, and then measuring that piece of string. Okay, that gives you the actual length of the circle here. We then talked about radians, which is another way to measure around a circle, like an angle or an arc measure. Instead of in degrees, you can measure it in radians. Okay, and it's just a conversion. That's all there is to it there. Okay. And remember, when we do radians, we don't multiply the pi in. We leave it in terms of pi. Okay, we don't multiply that pi through. Why is that? Because otherwise, I think the reason is because when you multiply that pi in, suddenly you go from something that looks kind of nice, to something that's very decimally. Yeah, decimally. Okay, not as nice to work with. Pi over 4 is also, by the way, when you see that, this is rounded, right? It's not precise. Pi over 4 is precise. That is what it is. Pi divided by 4. That's an exact value. You haven't rounded at all there. Here we've rounded.
You would have to write that whole number out.
Well, again, you think about this. That's not the end of this number. Pi over 4 is this forever. It goes on forever, never repeating. So that's why we're always rounding whenever we do this kind of calculation. Here, it's precise. All right, let me give you guys your assignment here.